Warahmatullahi Wabarakatuh. Dear students, in today's class we will learn how to solve orbital speed problems. Last class I told you, I gave you an assignment to do two questions, but some of you have said that you said that you won't be able to do the second question because it's quite tricky. So today I'm going to show you how to do that second question. Okay, how to solve the question, how to do all those conversions, and how to use the table which is there in the chapter itself, and derive the values and solve the problem. Okay, so and I'm also sending you a few questions as a homework, as an assignment to you. Okay, so the question which I gave you last time was there in the textbook. Let me show you that question again here in this video. So this was the question, right? So let me read the question. It's question number 4. It says, if the Earth is approximately 150 million kilometers from the Sun, calculate the speed at which the following planets are moving around the Sun. The information you need is given in the table on page number 261. Okay, so you need to find the speed of Earth, which is subdivision A, question subdivision A, and subdivision B, which is Jupiter. So you have to find answers for both of these planets. Okay, orbital speed. Okay, so we're going to use the same formula, orbital speed formula. V equals 2 pi into r over t, that is divided by t. The same formula we are going to use. Okay, no other formula. Okay, the same formula. Okay, so inshallah after this class, maybe on Monday we will have a test. That is, I will be sending you a few questions. You have to do it on paper and you have to scan and send me, and I'll be giving you marks. Okay, so please remember, boys and girls, that all the marks which you are getting in online, classes, they will be considered for your internals. Yes, and internals give you a boost in the final gradings. So internals are very, very important. Okay, so each and every test or every assignment, it's very, very valuable. You can't just say that tomorrow inshallah I'll do my best tomorrow. It's not like that. It's not happening. Okay, so you have to do well every day. You have to work hard consistently. Okay, you cannot delay, you cannot procrastinate your work. Okay, so every day when you get your assignment, when you get your homework, okay, that's it's your duty to do it on the same day. Okay, so I hope that you will follow it inshallah, and it will be serious enough. Rahman Rahim. Dear students, inshallah, today we are going to see this fourth question. Some of you had some doubts regarding this, and this question is quite tricky, but still it's easy enough to understand. Okay, so let me read up the question. Question number 4. It says, if the Earth is approximately 150 million kilometers from the Sun, calculate the speed at which the following planets are moving around the Sun. The information you need is given in the table on page 261. Okay, so this question is asking us to find out the speed, that is the orbital speed of Earth and Jupiter. The question gives us the distance of Earth from the Sun, okay, which is 150 million kilometers. The question doesn't give us the distance of Jupiter from Sun. From the table we have to take that value, okay, and doesn't even give us the time, okay, and even the time we have to take it from this table from page 261. Okay, so first let's find out the value, find out the answer for this subdivision A, which is Earth. Okay, so let me show you the working on paper, inshallah. Okay, so basically we have to use this formula, which is V equals pi 2 into pi into r divided by t. Okay. So this is the formula. Basically, we have to use this formula. But before that, we need to have, we need to do certain, you know, conversions. Okay. So the first thing what we need to find is r. So let us do certain conversions. Okay. So let me show you the table now for a while. There are certain values which you have to take it from the table. Okay. But before that, you know, r is the radius. Okay. So the question says that the earth is 150 million kilometers away from the sun. So what we need to do here is we need to add 6 zeros. Okay. Okay. Which is 150 followed by 6 zeros. Okay, so I have just missed one more zero. Let me add one more. So this is in kilometers. Now we have to convert this into meters. What we need to do is we need to simply, you know, we need to multiply this with 1000, and finally we get 150 followed by 9 zeros. Okay, followed by 9 zeros. So this is the radius. Okay, so directly we can, you know, substitute this here. Okay, so with 9 zeros, 150 followed by 9 zeros. Okay, so the time period. Okay, now the table says, the table which is there in page number 261, the table says that, you know, yeah, time for one orbit of the sun in Earth years is 1 year. Okay, so we know that 1 year equals 365 days. So we are gonna use this value 365 days here, but we need to convert this into seconds. Okay, so to convert this into seconds, okay, simply we have to multiply this with 224, then again by 60, then again by 60. Okay, so this gives you a value which is 3153600 seconds. Okay, so to convert this 365 days into seconds, we have to multiply with 24, because each day has 24 hours, and every hour has 60 minutes, and every minute has 60 seconds. So that's why we need to multiply with all these numbers, and here we get the final answer, which is 3153600. Okay, so after simplification, okay, so the answer we get is 29,886 meter per second. Okay, so that's it. That's as simple as that. Okay, now when we go to the second subdivision, where it says to find out the speed of Jupiter, now we have to do certain, you know, things with regards to the values here, which is given in the, you know, in the tabular column. So again, it's 2 into 2 pi into divided by the time. So now what is the radius here? So the book says, the tabular column, it says that that the Jupiter, it takes 12 times more than the Earth. Okay, it takes 12 times more time than the Earth. So what do we need to do is we need to multiply, you know, so we need to multiply the 365 into 12. Okay, and then we need to substitute in the formula. Okay, then distance from the sun, again it's 5 times more than the Earth. So again we have to multiply 150 million with 5. okay, because it's 5 times more than the distance of Earth. So that is why we have to multiply this with uh, the 150 million. Okay, so R is 150 million multiplied by 5. So what do we get? We get 750 followed by 6 zeros. Then we convert this into meters. Then again we get 750 followed by 9 zeros. Okay, so this is your radius. So let's readily substitute here 750 followed by 9 zeros. Then comes the time. Okay, so how do we now how do we take this time? Okay, so Earth, it takes 365 days to make one revolution around the sun, but for Jupiter it takes 12 days to make one revolution around the sun. So what do we do here? We just multiply this with 12, then we get an answer, okay, which is 4344. Okay, now we convert this into seconds. What do? We do the same thing. We multiply this with 24 into 60 into 60, and the final answer is 3784.32000 seconds. Okay, so this one we directly we substitute here. Okay, then when we simplify this, this one, we get the final answer as 12452 meter per second. That's it. That's the final answer. Okay. Now this is the speed of Jupiter. Okay, and this one is the speed of Earth. This is the speed of Earth, orbital speed, and this is the speed of Jupiter. Okay, so this is how we need to simplify. Very important things are these. How do we calculate this, convert this into, for example, this is in kilometers, we convert this into meters, and this one is in days, we convert this into seconds, and the same goes with the second subdivision as well. We do the same to find out the speed of the Jupiter as well. Okay, so I hope that this was very clear. If you have any doubts, inshallah, you might raise your doubts. You can send WhatsApp, or you can post it in Google Classroom. Okay, so I'll be giving you a couple of questions. That's your homework. Okay, so you have to simplify and find out those answers of those questions. Okay, Assalamu alaikum.